Okay, I see it's noon. So welcome everyone to ARC Advisory Group's Smart City Forum. This session is entitled IoT and Smart Lighting. I'm Jim Frazer, Vice President of Smart Cities here at ARC Advisory Group. And in addition to that position, I volunteered in the past with quite a few standards and trade organizations. In the past, many of you know I chaired the IES, the Illuminating Engineering Society's Roadway Lighting Committee. I have developed the interoperability application interface for the US DOT's street lighting program, known as NTCIP 1213. And currently, I chair the IEEE's Smart City Planning Standard P2784. If anyone is interested in participating in that effort for systems engineering of a smart city, feel free to reach out to me. But I'm very happy to have a roster of presenters and panelists today that are leaders in the industry. First of all, we have Toby Morgan, LED Program Manager for the Climate Group. Toby has over 13 years experience in the energy efficiency and climate change sectors, working across both public sector and nonprofits. He is extremely passionate about tackling climate change and sees energy efficiency as the #1 priority action to reduce global CO2 emissions. He joined the internationally renowned NGO, the Climate Group, in 2017 and is the LED Program Manager, working to accelerate the global adoption of energy efficient lighting and linking it with exciting developments in smart building and smart city initiatives. So welcome, Toby. Next, we have Kevin Fitzmaurice, Principal Engineer, Lighting and Smart Services at Georgia Power. Kevin has over 35 years of lighting and energy-related experience. He currently serves as the chair of the ANSI C136 Standards Committee for roadway and area lighting products, and is a member of several other ANSI standards committees related to lighting and metering. He's a longtime member of the Illuminating Engineering Society, currently serves on the Roadway Lighting Committee and the Street and Area Lighting Conference Planning Committee. He's also lighting certified by the National Council on Qualifications for the Lighting Professions, known as NCQLP. So welcome, Kevin. Also joining us is Raimundo Rodulfo, Director of Information Technology and Chief Information Officer at the City of Coral Gables, Florida. He joined the City of Coral Gables in 2004 and currently leads strategic planning, oversight, and management of citywide IT operations, infrastructure, and smart city initiatives. Under his leadership, the city has received numerous awards, including first place in the Digital Cities 2018 for cities of up to 75,000 in population, and has been recognized as one of the 8 smart cities to watch in 2020 by the State Technology magazine. Prior to joining the City of Coral Gables, he spent 10 years in the private sector working for various companies such as Bell South, Siemens, and NCR. During this time, he also assisted on technology projects for Motorola and Lucent in Chicago and Agilent Technologies in Silicon Valley. So welcome, Raimundo. Noiseux is the Executive Vice President of Dimonoff. Dimonoff is a true pioneer of urban asset management and an innovator in the design of wireless control platforms. Since 2006, Dimonoff has been serving cities, utilities, and businesses all around the world. They offer edge solutions and open, scalable IoT platforms designed to increase the sustainability and safety of infrastructures, as well as the quality of life of people all around the world. With well over 300 projects deployed in a variety of environments, Dimonoff is recognized as a major player in the smart street lighting sector, and is involved in 2 of the 5 largest street lighting projects in the world. And lastly, but certainly not least, Martin Mercier, Strategic Marketing Manager at Cooper Lighting Solutions. Martin is a Senior Product Manager at Cooper Lighting Solutions, formerly known as Philips Lighting, a global lighting manufacturer, leading the lighting industry revolution into IoT-driven solutions. Since his early days in R&D, he contributed to develop and to launch the first Philips Lighting LED light engine platform deployed in multiple brands and manufacturing sites across the Americas. Shortly thereafter, he helped bring successfully to market early cloud-based technology lighting systems for public and private customers in the Americas. His insights and ideas helped strengthen the overall effort in pioneering new technologies for Signify and now Cooper Lighting Solutions and the lighting industry in general, bringing problem-solving solutions to our smart city and smart building customers. So welcome all of you, and thank you very much for attending today. With that, we'll move into our presentations. And Toby, can I ask you to share your screen?
Sure. Okay, hopefully you can all see that.
Yes, we can.
Perfect. Great. Thank you, Jim. Really appreciate the opportunity to be here today. Great to be with you all. So I'm going to give a bit of an overview of the subject and what the opportunities for cities and utilities in this area. I'm Toby Morgan, as Jim said, from the Climate Group, and we run a number of different programs with both with business, with cities, and with state and regional governments all over the world. Our goal is a world of net zero carbon emissions by 2050 with greater prosperity for all. We're based out of London, but we've also got regional offices in New York, New Delhi, and Beijing, and we're setting one up in Amsterdam as well to target those key markets. And why we're especially interested in LEDs and lighting in particular, because you know, it's a huge global energy user. So around 6% of global CO2 emissions are coming from lighting. And obviously, if we swap that out to energy efficient LEDs, we can make a considerable dent in the emissions. And LEDs, lots of people will be aware of this, but it's just the scale of the energy savings from those. So you're getting instantly sort of 50 to 70% energy savings, up to 80% or more when coupled with smart controls. So it really is a game changer in terms of energy efficiency. With other measures, you know, with air conditioning or with DC motors in industry, you might get a 5, 10, 15, 20% saving. But with LEDs, you're going straight in with 50 to 70%. So massive potential energy savings there. We've been working to accelerate the global adoption of LEDs for over 10 years now. And we conducted a number of trials in 2012, which we called the Lightsavers. So obviously there was lots of talk about LEDs and the potential for savings, but we wanted to have some real world case studies and examples. So we assessed the different technologies, the reliability, and also public acceptance to that as well. So if you go on our website there, you can download the technical reports, and there's a number of different individual city reports as well. And how we work, obviously at the moment, we're all confined to our homes, but we have over the years done workshops all over the world. So we, you know, try and get stakeholders together, get everyone talking, get that peer-to-peer learning going, and also present some real world case studies and best practice examples to try and, you know, accelerate action all over the world. And what we also did to try and raise awareness of this issue and all the benefits to that, we called out a public, that all public lighting should be LED or as efficient by 2025. And we did that with our partners Signify. And that was to really, you know, highlight this issue all over the world and saying, you know, it's a great thing for cities and for utilities and for citizens as well that we can do this. And just looking at some of the benefits here. So obviously, if you just do the LED swap out, that's great. You get the energy savings. But then you can basically continue adding smart capabilities. So if we add local proximity sensors, lighting sensors, you get further savings. And then a real big game changer is if we add that connectivity. So if the lighting around the city is connected to a centralized management system, it gives huge asset management capabilities. So you can plan maintenance, plan scheduling, get energy readings, that type of thing. So it's a real game changer for cities and utilities to be able to do that from the comfort of their office and not have to go around street by street looking at outages and repairs and faults. And then obviously using that connectivity. So we're using the street lights all over the city as that underlying infrastructure that can then help facilitate smart city Internet of Things type projects. So embedding sensors and monitors onto the street lights, onto the luminaires and inside the poles. We can hopefully gain lots of interesting data around how a city's operating and use that data to gather insights and data intelligence to hopefully enable cities and utilities to run their cities more effectively, more efficiently. And it's estimated that those smart city capabilities could be worth over 2 trillion by 2025. So real huge opportunity. What is key with all these types of projects is they're flexible, they're interoperable, so different manufacturers work with different bits of kit. They're also future scalable, so cities or utilities might just not be that far along in their thinkings, but to enable that they can be connected, and they are connected, and then you can do those smart cities into the future when you get there as a city. And also data security is a real key as well, so ensuring that these systems are secure and the data is secure as well. And just some examples of the types of data that could be collected in a smart city type scheme. So we can look at things like traffic monitoring, pedestrian numbers, weather, radiation monitoring. So hopefully gathering a good picture on what's going on in the environment, but also in the city itself, to hopefully plan and schedule services and city opportunities, and using all that data in a smart way. Obviously, if we are going about data collection programs, there's issues around data. So that's one of the key topics at the moment, is who owns that data, who can access that data, is that data secure? So obviously that's got to be a consideration when a smart city initiative is undertaken. And just a couple of case studies now. So City of Los Angeles, it's obviously a well-known case study now, but they were an early adopter. They started their scheme in 2009. They've now done around 185,000 streetlights, so pretty much the whole city. From that, they're getting around 64% energy savings compared to the old technology, almost $10 million per year in electricity savings, an additional 3 to 4 million, I think, is in maintenance savings as well. So that was one of the things that wasn't quite anticipated when LEDs first came on, with the massive maintenance savings that are possible. And obviously, due to the huge energy savings, they're saving around 65,000 metric tons of CO2. So good for the environment as well. And then in sort of 2015-16, they started expanding on their connected lighting and doing some smart city type initiatives as well. They're even looking into leasing some poles out as well to telecommunication service. So that's actually bringing in income to the city as well. So you can use those types of smart technologies to potentially earn some extra revenue for the city. And then another case study here, Smart Street Lighting New York. So this was, the governor announced this in 2018 that NYPA were going to implement the scheme, and the goal is to swap out 500,000 to 500,000 streetlights to LEDs by 2025. And obviously they're experiencing, I think, they're well on target to hit that number, and they're getting huge energy savings, huge maintenance savings. And they're also finding the improved quality of light. Residents are enjoying that, improved comfort and safety for the communities across the state in those various cities. And how NYPA are operating is a full turnkey lighting service. So they're doing absolutely everything for those cities, which takes a lot of the pressure off those cities involved. So that whole service is taken care of. And then they're using that platform now to develop their own smart city initiatives. So that's a really interesting case study from New York State there. And just what are some of the barriers, and why is some of this not going as fast as we'd like to in many places? So obviously it's quite a mixed landscape in the US. Various stakeholders are involved. So we've got some cities own and operate all their streetlights, some utilities own and operate all the streetlights in their areas, or it can be a mix of both. So there's various routes that can be taken to going about these projects. What can really help is having those regional level or state level energy efficiency organizations that can help with some of the technical detail, that they can help with funding, and also having that state level guidance as well from the state utility commissioners. Some states are well set up and they've got tariffs available for LEDs, and some are a bit further behind. So we'd like to see more state level support for those cities that and utilities, so they can go ahead and benefit from LEDs. So like I said, yeah, some of these state level, regional level type policies and legislation can really help build momentum in this area, so it can unlock large scale funding. If investors know that there's sound policy, sound legislation in those states or in those regions, that can really help push this subject along. And just some of the kind of challenges and opportunities in this area as well. So there's not really a one size fits all approach to all this. So, every city has a unique history, different infrastructure, the way it's evolved over the years, different financing capabilities. So it really does need that baseline analysis and work before you actually undergo an LED scheme and a smart city scheme. The business case development remains a key challenge, especially for smart city initiatives. So, with LEDs, it's fairly simple to work out a payback period of return on investment. But then these additional smart city IoT initiatives, it's a lot harder to prove the business case for those. We know that, there should be benefits from that, but how do you actually put that on a balance sheet or in a business case? So we need more real world case studies and examples that can help push those ideas. Obviously, the cost of LEDs has fallen a lot in the last 10 years, especially. But what can help is some really innovative funding approaches. So I'm sure Kevin will cover this with Georgia Power's example, but things like light as a service. So, a city might not be able to do all this themselves. Can they get some collaboration with the utility or with those energy efficiency bodies, like we said, that can really help push this along? And high level coordination and political buy-in can really help, which I'm sure Raimundo will cover as well. Having a high level mayor or, a chief information officer or someone like that can really coordinate this from a high level and push action, because if it's just left to the individual departments, it might be a tougher sell to the people that hold the financing. And we know that some utilities are really leading from the front in this, but others are disincentivized. So it's not really, set up for them to benefit from LEDs. So can we decouple energy use from profit, which is the case in some places already? And like we said, that key to get these programs going is state and regional level support. So we'd love to see more states adopting energy efficiency targets or LED targets especially. And as the climate group, we're keen to work with any stakeholders and partners out there. So please contact me afterwards. I'll put my contact details up. So that was a brief whistle-stop tour. I hope that gives a bit of an overview, and looking forward to hearing the case studies from the other speakers. We've got a guidance document there on our website as well. So if you go to our website, you can download that, which gives lots more information, and my contact details are there as well.
Well, Toby, thank you very much for that. That was extremely insightful. I'm looking forward to asking you a few questions. Kevin, can you give us some insights from your experience with Georgia Power and street lighting controls and street lighting metering?
Sure, I'd be happy to. Let me share my screen here. Hopefully you all are able to see it now or soon. Jim,
yes,
it doesn't look like.
Go ahead.
Are you able to see it?
Yes, we can. Go ahead.
Okay, thank you. So thanks for giving me this opportunity. Again, I'm Kevin Fitzmaurice with Georgia Power, and I'm in our Lighting and Smart Services division. I'm going to be presenting to you a little bit about what we do, how we do it, and the utility perspective. This presentation will cover things like network lighting controllers, the Zaga Book 18 connectors for sensors and things such as this. So we'll just dive on in. And first of all, we're just going to quickly hit our mission, our vision and mission at Georgia Power's Lighting and Smart Services. We want to be the most valued and trusted utility lighting and smart solutions provider, and we want to earn customer loyalty by delivering exceptional value through lighting and smart services. And as Toby alluded to, the way we do this is lighting and controls as a service. We've been doing, lighting as a service for, I guess, 50, 70 years before it was a thing. We've always kind of done this. In our case, generally what's happening is we put all the capital up front, build the system and maintain and monitor the system. The customer pays a monthly service amount, and that's kind of a different business plan than a lot of people do it. Georgia Power, what do we do? This is a map showing where we're at for those people that aren't familiar with Georgia Power. We cover the state of Georgia in the United States. We're an investor-owned utility providing electricity to 2.6 million customers. In that footprint of the state of Georgia, we own, operate, and maintain about 900,000 outdoor luminaires. I say outdoor luminaires because it's broken into two categories, roadway and area. So we have about 350,000 roadway luminaires and about 550,000 area luminaires. Those area luminaires are in like parking lots or shopping centers and malls and universities and all types of applications, not on roadways. We also provide smart services such as monitoring and control of the outdoor luminaires using network lighting controllers, video and license plate recognition systems, gunshot detection, environmental monitoring, pedestrian vehicle counting, and we are doing a lot of small cell installation of 4G and 5G on our lighting poles. That is an everyday, unbelievable business right now. What are we doing? We are converting 900,000 luminaires to LED with network lighting controllers. Now, that term NLC is an industry standard term, and IEC, IS, ANSI. A lot of people refer to them as smart nodes, and a lot of other nicknames. We're monitoring all LED luminaires with wireless network and central management system. So we have this wireless RF network, and then we have a central management system where operators monitor our system. And we have converted, over half of our system has been converted to LED and NLCs, and we will continue until we're done. We're utilizing digital communication protocols. So we do not use 0 to 10 dimming protocols, things like analog type protocols, which are a one-way, not a bi-directional communication protocol. We utilize DALI, DALI 2, and D4I in all of our LED luminaires. We're also using sensors for additional functionality, which I'll cover some in a few minutes. And we're actively participating on lighting standards committees such as ANSI, IES, and many others. Why do we use digital communications? A lot of people call me about this. Why use DALI? Why do this? Why do that? We wanted to provide a two-way communications path between LED drivers in the luminaires and the sensors and the NLCs. We want to be able to talk in both directions. 0 to 10 will not do this. DALI, DALI 2, D4I were selected because they're established lighting protocols with published standards. They have a positive track record, and they provide the functionality that we need. So it was an easy choice. What about sensor interfaces? Let me hit this. This is very important for a few minutes. There's 2 points on a luminaire where we have sensor interfaces. We always have what's known as the 7-pin receptacle on top, which is your locking type receptacle, where we put either a photo control, which is rare, but normally we put a network lighting controller in the top of that luminaire. That network lighting controller connects back to our central management system, but it also talks inside of the luminaire into the luminaire and asks the driver for information about everything about that fixture, and carries that back to our central management system in a machine-to-machine method with no human intervention. So on the bottom of the luminaire, we have the Zagabook 18 connector. It's also locking type, where we can install different types of sensors. Now, we do not have this on all of our luminaires, but when we anticipate using sensors, we will use that Zagabook 18 connector on the bottom. So why did we make these selections? Well, we picked the 7-pin on top because it was a standardized sensor interface for photosensors and for NLCs. Same for the bottom. It was Zagabook 18 was standardized. The interface needed to be locking type so we could easily install and remove sensors, top and bottom. The interface allowed us to future-proof our luminaires. We don't always know what the future holds, but we want to have the luminaire built to handle the future. And again, I explained that bottom block there. We selected Gonzaga Book 18 after selecting the 7-pin for the top, because Gonzaga Book 18 really gave us what we needed for the bottom for those types of sensors. And you know, some people ask us about Gonzaga and D4I, and does it meet Georgia Power needs? And yes, it absolutely does. I mean, we are building for the future. You know, this platform provides a standardized environment for digital communication between our drivers, our sensors, our NLCs. It allows Georgia Power to future-proof the luminaires, like I mentioned. It allows for easy installation and removal of sensors, and it provides a standard framework for manufacturers of the drivers, the sensors, the controllers, the luminaires, to all use to design and produce the tools the lighting industry needs. We are trying to avoid one-off products. We want to have things that are standardized and that you know, can be used by other end users like us. And then I'm going to roll in and conclude with a case study. This is one example of how we utilize these devices together to give the customer exactly what they need, and also to provide a service that we can install and maintain going forward. This is Georgia Ports Authority down in Brunswick, Georgia. I'm going to call out a few manufacturers here only because they all work together to make sure that this implementation worked properly. And it was a good example of how manufacturers can work together and ensure the product, you know, works as intended. In this case, we used Cooper Lighting Solutions Navion luminaires. We had Signify sensor ready drivers, which are D4I drivers. We have Legrand watt stopper presence sensors, or some will refer to them as motion sensors, and Talenza network lighting controllers. The configuration allowed for low lumen output during nighttime hours unless there was activity detected. Whenever there was activity detected, it triggered a full lumen output until there was 15 minutes of inactivity. And then it would go back to low output. So basically, when they're unloading ships at this facility, they need full output. But 80% of the time, there's no activity in the evening, and they don't need to be running at full power. And we also don't want to charge the customer for full power when they're only using full power when they're unloading the ship. And the next block will kind of explain what we do there. This assembly provided automatic low and high lumen output, remote monitoring, key thing here, energy metering, and remote operation control when needed. Our NLCs are revenue grade certified energy meters, just like the meter on your house or your business. They meet the same requirements of accuracy. So in this case, we actually meter each one of the lights at the facility, about 200 or 300 lights probably. And we measure the output, which changes all the time based on activity on site. And then we have a virtual meter, which all these 300 NLCs roll back to, and we produce a bill for the customer for the actual energy they use, not what we estimate, not dusk to dawn. It's what they actually use during those periods with a different activity. So the end result was the customer had a system that reduced sky glow near a sea turtle nesting area. This was huge, and it reduced energy usage, which was huge too. But this is very close to Jekyll Island, Georgia, where sea turtles nest. And so we needed the output of these lights to be in the low lumen output mode most of the time, unless they were unloading a ship where they were allowed to go to high output for safety reasons. And that wraps up my presentation, and I'll turn it back over to Jim.
Well, thanks, Kevin. Great insights. Looking forward to asking you a few questions as well. Next up is Raimundo Rodulfo, who's going to share some insights from Coral Gables that expand beyond just the streetlight. Take it away, Raimundo.
Thank you, Jim. See if I can share my screen here.
We saw your screen, and now we do not.
Okay. Allow me a second. Let me see if I can share it now. Is it okay now?
There it is.
Perfect. Thank you.
Great.
Thank you so much. So my name is Raimundo Rodulfo. I am the Chief Innovation Officer and Director of Information Technology with City of Gables. I also volunteer as co-chair of the NIST GCTC Data Supercluster. And I'm going to talk a little about our IoT and smart lighting projects. And some of them, for example, have to do with improving specific parameters in quality of life, leveraging what we call Industry 4.0 to Quality 4.0. So it's a quality-centric program that starts at a vision of leveraging technologies like IoT, like AI, like machine learning and data science to improve specific areas. So in this smart city framework architecture, we have 8 interconnected strategic management frameworks. And the first one is around those focus areas like public safety, like data-driven initiatives, like sustainability, and also enterprise systems and interoperability between different areas that we provide service around the city. And IoT and smart lighting, they play a big role there. Basically, they are integrated into the cyber infrastructure of our smart city plan. And so all those areas from vision to focus areas and quality engineering and providing a foundation of network infrastructure that connects all those devices and provides also an engineering framework of a stack of technology that talks to each other, from IoT to data platforms to a smart city hub of services. So they have to work with interoperability, and that's where I'm going to explain how some of those frameworks connect those technologies. In the next slide here, let me see if I can move to the next one. You will see 2 of those frameworks. So in our focus areas of smart city infrastructure, the data that we collect from those smart lights and from those cyber physical systems and sensors, traffic sensors, energy sensors, environmental sensors, they provide insight that is leveraged, by urban planners, by traffic engineers, by public safety officials, by first responders during hurricanes and during the pandemic, as I'm going to show next. And they play a big role in public safety. So we have here to the right, you see our force framework is the smart city engineering framework, where we have this layer of Internet of Things, where we have smart lights, traffic and parking sensors, public safety, smart technologies, and environmental sensors and actuators, smart devices, smart kiosks, and robotics like connected drones and connected mobility in our city. And all the data from these systems is aggregated in our clouds, where we are able to correlate them and provide actionable insight to our stakeholders. And we do that in the final layer here, the Smart City Hub, where we provide through dashboards in our Smart City Hub public platform. We provide that data open to the public, to the stakeholders, to businesses, to first responders, to researchers in university, and to the public in general, to our ecosystem, which is the last layer here, where you see our ecosystem of people-centric, basically, and also businesses, organizations, those things that are connected now and are part of the ecosystem, and those intelligent systems that using AI and digital personas and digital reality are able to make sense of all that data to continuously improve quality of life. That's what we are doing here. So providing better customer service, providing better insight, and also helping our sustainability initiatives. So now going to the Internet of Things itself. So we have a multitude of systems that I won't have enough time to go over all of them. I will concentrate on the main ones that are related to our deployment of smart lighting. So we have street sensors that are measuring vehicle traffic, that are measuring pedestrian traffic, environmental impact or carbon emissions, and also noise. And we also have some of those sensors in water canals, measuring water quality and electrochemical parameters in the water, in our water canals. Very important during emergency management as well. And we have pilots that are leveraging those IoT sensors, optical sensors, and different kind of edge analytics to also count available spaces on the curbside, on street parking. Or in some cases, we deploy trailers with intelligence to run specific studies of traffic for bicycle or multimodal transportation analysis. And for our smart lights, our public works departments, they have that sustainability master plan. Their goal in 10 years, so from 2015 to 2025, is to have a 20% reduction in energy consumption, water consumption, and carbon emissions in CO2. And right now in 2021, they are at 14%, basically. So we are on target to meet that 20% goal of reduction. So they started by replacing all those traditional lights, the high pressure sodium lights and other old technologies with LEDs. So right now they finished replacing all the lights with LED in all the city facilities and also the downtown area and the business district area. So we, in our technology and innovation department, we took the opportunity, as I always said, when we are replacing those lights, we don't need them to have a brain for the beginning, but we need them to have a spine, because later we're going to put a brain on those lights. And that's what we have been doing. So I'm going to go to the next slide. I'm going to show you that recently, so in between 2019 and this month, 50 smart lights controllers have been installed in some of those major arteries in downtown, like Miracle. And because those lights were already converted, city-owned lights were already converted to LED. At the same time, the Public Works Department, they are working with Florida Power and Light, FPNL, also finishing most of those conversions and retrofittings to LED in outdoors spaces. But at least in the downtown area and other areas in the north part of Fort Gables, they have been already converted to LED lights. And we are taking the opportunity that those lights, they have a spine, they have that ANSI C136 standard 7-pin connector already in the overhead of those lights. We are putting those controllers there. So you see here the architecture of the system, and you see a photo of one of those lights that we have in downtown, where we have the controller on top of the overhead. But we also have other technologies. We have smart lights in the street ends that they have sensors as well and capabilities. And we're doing a pilot in our financial district with a new type of consolidated pole, a smart city pole. It's not a lighting pole, but it has all the technology that we have currently in multiple technologies distributed, all consolidated inside of the pole, like license plate readers, CCTV, Wi-Fi access points, and traffic sensors, all that technology together in one place, including also environmental sensors, measuring the carbon emission part. So I don't have enough time to go over all of these technologies, but I invite you to go to our Smart City Hub at coragables.com/smart city to see some of those technologies in action and see real-time data that we are sharing with the public on those. And this is a case study that we published to NIST and IEEE, talking about how we use that kind of data, cyber-physical data, during the pandemic, to measure the impact of the pandemic in traffic, water quality, environmental variables. And to the left lower corner, you see how we also gather energy data from those smart controllers. And I didn't mention it, but what are we getting there? We are getting, the controllers provide intelligent on-off switching, dimming control, GPS, power metering, sensor inputs, and we measure the health of those lights. If there's a light that goes down, so we know right away, and we are actually integrating that to our asset management system. So we generate tickets automatically from those systems. We have centralized management. We run reports on energy consumption, LED burn hours, automatic alerts, etc. So we have a lot of capabilities and automation built on those smart lights. So during COVID, you see in the lower corner how we gather some of that data of consumption. So you see the impact on COVID-19, that COVID-19, the pandemic had on energy consumption, as well of traffic and real-time data from water canal quality. And So when you get all that data together, you are able to do more analysis and correlation and provide that insight to officials and decision makers. And that's what we did. So if you want to learn more about that, we published those some of those case studies. We published a case study about all of our IoT implementation on smart city use cases on the IEEE magazine, IoT magazine of Comsoc, and that June 2020 edition. And we also published together with researchers of FIU. We provided a study on how we used data from cyber-physical systems to respond to the COVID-19 crisis on the American Society for Public Administration. We also published use cases on IoT, smart city data analytics for the NIST GCTC group, and also applications to smart water, using that for a water strategy. So you will see some of those use cases here if you want to learn more. We also apply sensing capabilities to drones using computer vision and AI, and in some cases also the as part of the payload of the drones for multiple uses. For inspections during COVID-19, we use them to inspect testing sites, as well as towers and rooftops, and many other use cases during emergency management and rescue recon during hurricanes. Other use cases, they have to do with parking. Now the new mobility hubs and parking garages, they come with smart lighting indoors capabilities, but we also have other sensors like ALPR and CCTV that uses computer vision to provide the analytics from parking garages. We connect that via API to our smart parking apps. Those are another use cases. We are aggregating all the data from IoT into an IoT platform. And today we use multiple technologies. So we are still trying to aggregate all the data in one place so we can apply supercomputer analytics for multivariate Gaussian models to provide some sort of a more insightful, high-level correlation between traffic, between lighting use, between energy, between environment, and have a more holistic view of the analytics. That is not only energy, it's not only transportation, it's more like a horizontally integrated interoperability model. And basically, we partner with all these organizations, science, academia, industry, government, and nonprofits, and that's what gives us those enterprise capabilities to do some of these analytics. So thank you so much. It's a pleasure to be here. Thank you.
Well, thank you very much, Raimundo. That was a great overview from three different perspectives of our presenters. Both first a worldwide view from Toby, Raimundo from the public agency, City of Coral Gables perspective, and then of course Kevin Fitzmaurice in regards to the utility perspective. Of course, the suppliers have a perspective on this as well. So I'd like to now move to Noiseux of Dimonoff to tell us a little bit about what solutions does Dimonoff address?
All right, thank you, Jim. Yeah, Raimundo did a good job presenting all the options that they're already deploying out there. So that's a very good base for a discussion. As far as what we see as that is gaining traction, because I know we hear and read about tons of stuff that can be deployed, but in real life, what really is getting traction right now, level sensors in general, for water, for sewers, for snow up here in Canada. So having the right amount of what's measured out there and taking the proper decisions with those sensors is important. So that's getting traction. Parking occupancy. We just saw the example in Raimundo's presentation. Curbside parking, where obviously right now with COVID, the downtown areas have sort of gotten empty in some cases, but I don't believe it's going to stay that way. So finding open space for parking is always a challenge. So that has a big impact on CO2. Until we have everyone has a electric car, we're still using fossil fuels. So that's gaining good traction as well. We've seen a few projects now with smart poles. There's tons of stuff you can attach to those poles. So digital signage is one of the interesting one. Blue button for calling for help. That's gaining traction as well. environmental sensors in general, although they're not as spread as we see in the street lights, obviously, but for measuring wind speed, rain gauges, temperature, humidity, CO2, VOC, very standard. And the good thing is that those sensors manufactured by very large companies are getting so cheap that they're easy to deploy. I don't see that being deployed at every corner or at every street light. Doesn't make sense. You don't need to have temperature every 10 feet. But I mean, this is other additional stuff that is getting deployed. We've had projects also recently with DMX controller. So where there's parks, there's activities, there's tourism area, adding a DMX control to make live scenes with projections, that's getting part of the systems. And having a smart street light system around that allows you to actually dim the lights where there's a projection, and you can have a nice show. And then afterward, you bring up the levels back to normal. Cameras analytics, although there's a big debate on recording, and we see a few lawsuits out there. So we're being very careful on that. And then smart poles I mentioned with bollards, color bollards, it can indicate a problematic area. Yeah, and we're doing a few pilots right now for sound recognition, not only gunshot, but other sounds like a car crash and people yelling and other stuff like that. So that's stuff that we're deploying and working on right now.
Great. Certainly, last but not least, Martin, you've had a long career with Philips Lighting and now with the Cooper Lighting Solutions division. Can you tell us a little bit about your current role and current initiatives?
Sure. Why not, right? Yeah, I've been with Signify a long career. I'll be careful with that. With still feel it was yesterday I started, but 15 years. But when I started, actually, we had no LEDs at all, especially for outdoor. It was basically old lamps you could control. And I was brought in to connect the lights, and there was not much to connect at that time, believe me. But since then, just listening to Daniel and Raimundo, it's unbelievable what we're in. And lately, I've been involved in indoor and outdoor controls, still I am. The last 3 to 5 years, I've been involved in standard committees, mostly NCC 136 and some global consortiums, EIA and Zagabook 18 works and 20 now, from a Signify standpoint. And what's really interesting for me, and it still is, was and still is interesting to me, is how we're going to connect all these things together. It's amazing what we can put on a pole. And Daniel mentioned smart poles. I mean, I can tell you that all the devices that are put on poles right now, it's unbelievable, sensors and all these things. So I've been spending a lot of time seeing how we can put those things together on a fixture or on a pole. And something interesting happened, lately, end of 2020, with the release of D4I standard for internal luminaire communication, which some of you are aware of. I think that will be a great tool for our customers and manufacturers. Obviously, Cooper Lighting Solutions, Dimonoff as a control system manufacturer and sensors, as Kevin mentioned, to come together and kind of simplify integration of all of this. A lot of these projects are peak projects, and then it's hard to think about 5, 10, 20 years ahead. But we make sure that we sell to our customers future-ready solutions, right? So they can improve. And I mean, we have so much to learn. We're just starting here. But yeah, that has been part of my focus, improving and accelerating and educating our lighting and outside of lighting communities. How we do that? How can lighting help you with your smart cities, connected buildings projects?
Hey, that's great. We have numerous questions that I've grouped, but let me start with just a general one. We've heard a range of applications, and particularly for an end user, city manager or a building manager, it's tough to choose which one might be where do you start? We know lighting is ubiquitous, it's everywhere. Every lighting fixtures are now networked nodes. What applications are truly the lowest hanging fruit in terms of impact, cost effectiveness, or other other measurability indexes. I know, Kevin, you talked about gunshot, environmental license plate recognition, some other things. We all come from, we've got representatives from each stakeholder community here, a controls manufacturer, a lighting manufacturer, a utility, a city, and an NGO. I'm guessing you all have different perspectives. So jump in. Where does an end user go first? What are the most compelling applications?
Well, I'm happy to start the conversation if that helps. To me, at least from our perspective, but I think from many perspectives, from utilities or municipalities and things like that, is the low-hanging fruit is obviously it's installing LED lighting and replacing your HID lighting, your legacy core and coil ballast type thing. I mean, there's a 60% energy savings right off the bat. Control wise, install network lighting controllers while you're doing that. It makes it a cost-effective venture if you do it at the same time. If you do it 2 separate times, it adds a lot of cost to the conversion, and you lose a lot of the elegance and beauty of it. I say that not in aesthetics. I mean, as far as the workings of the system, how it works together, that elegance. The reason I say lighting controllers are a good first start is we have seen way too much paralysis by analysis in the industry in the last 10 years, where people have held off on implementing lighting controls because they're waiting for the next best thing that can do everything under the sun. And because of that, it's like waiting for the next smartphone to come out or the next computer to come out. You never buy anything, you never implement anything. You keep old technology. We say go march forward, take action, do something. Lighting controllers are much easier to implement because they require low bandwidth. They do not require very high bandwidth. So you can do this with modest RF networks. And that's what we do for lighting. When we're going to use wireless networks for backhauling higher bandwidth requirements like surveillance or a lot of smart cities type information, then we will employ something like 4G, 5G, and possibly Cat-M in the future, where it's a little more cost-effective method to do it, and even narrowband IoT for low bandwidth requirements. So to summarize, I say do your lighting controls as soon as possible when you convert your luminaires, and then when you need higher bandwidth requirements, attack those with a type of controller that will handle the requirements needed. But you don't need it on everything. Most lights just need low bandwidth. They need a good lighting controller, and they need to give the central management system the ability to view that item and know when there's a problem and allow us to go fix it quickly before the customer even knows there's been a problem.
Great. Daniel, you want to add on to his perspective?
I'll bring it up to a different view. I think the lowest, and from we've seen in deployments, I don't know why, but most cities or utilities we work with don't have a clue. Well, they have a clue, but they don't have the correct information on what their assets are. And that's a big gain of what's happening when you're doing a conversion to LEDs and adding controls, obviously. I hope everyone is going to jump into the DI4 bandwagon so that we get the information, proper information, not entered manually by someone or writing up on a Excel spreadsheet. So one of big discovery I've had over the last few years is, I mean, I've got cities that discovered that they had 500 lights more than they thought they had. Just all of a sudden, they have 500 more poles to manage. They have, I've even had the customers converting fixture that weren't theirs. They converted some DLP lights because they thought it was their own lights. I mean, that's a big aspect, I think, that can really gain from. It's not smart street lights. It's just the new systems. When you get up to speed with is available today, I think these are major impacts on how we do things and manage things.
Well, on this question, I'm forced to go to Raimundo. Raimundo, if you could remember back when you started on your on your effort here. What did you do on day one in terms of selecting, what got networked first? What applications did you want to implement initially?
I would say it starts with the alignment process, so aligning our smart city strategy to the strategic goals of the organization as a whole, but also to the needs and priorities of our citizens. There were some areas that required faster attention than others, and each community is different. So in some communities, maybe the mobility and transportation or public safety. So we want to attend them all, but we tailor the order and the prioritization based on that feedback that we collect from public sentiment and priorities and needs from our community. So we started with areas like public safety, digital transformation in terms of efficiencies, organizational transformation with Lean Six Sigma citywide processes, trying to improve processes before we introduce the technology to a process, improve the process with quality engineering, and also, public safety. We started with a lot of public safety related applications of IoT at the very beginning.
Great. Our next question is really about sustainability. And Toby, let's pose this one to you to start. It's a follow-up on our first question, that impact and effectiveness really isn't as comprehensive as sustainability. Sustainability has the three pillars of protecting and enhancing the natural environment, protecting and enhancing the human quality of life, while doing those first two in an economically responsible way. How does LED and IoT-enabled lighting address sustainability and maybe even resilience?
Yeah, thanks, Jim. Really good question. I think where we start with this is, you can do a lot more intelligent things with your lighting, with your data that you can collect from that. So, you're not just getting the energy savings, which are massive anyway, which, goes towards a big chunk towards the sustainability goals, is this huge energy saving. So let's not forget that right at the start. But then with LEDs, we can be a lot more intelligent with our lighting. Like we've said about, Kevin said about some of the nature applications that they've done. So using those lighting technologies in an intelligent way. And we've seen US Department of Energy, US National Park Service using LEDs in intelligent ways as well to not affect wildlife in those national parks. So I think at the very start of when LEDs started going in, there was some negative backlash, negative press about that, because there was some poor examples put in, early when these projects started going in, and that was a problem with how the projects were implemented and not with the technology. So I think that's where some of the negative headlines came from. But I think now, it's a mature technology. We know we can use all this information intelligently. And like Raimundo has outlined, all these aspects are really linked within a city as well. So you're not just looking at your LEDs, you're looking at traffic monitoring, you're looking at parking, you're looking at public transport. That all links in with air quality as well. So if you can, point people to a nearest parking space without them driving around the block 4 times, that improves air quality. If you can provide information on better, to ensure your public transport works better as well, that can encourage more people to use public transport and not use their car. So I think it's linking all these different aspects. And I think it goes back to that initial question, is the previous question of, where do you start with all this? And like Raimundo said, I think you have to know what your priorities are first before you go about starting any project. So we've seen some cities just go all out, think we're going to collect all this information and then do something with it, and then have all this data and think, not sure where to go from here. Whereas if you outline your priorities first, say it's improving air quality, it's improving traffic, it's improving transport, then that gives you a great baseline to then go about, right, what do we need to do in terms of our smart cities?
There actually is a follow-up question on this subject. What about stakeholder management for public projects? There's quite a few stakeholder communities in public projects. And what about internally, siloing of different agencies. So maybe Toby, you take the stakeholder management, and Raimundo maybe take the silo question.
Yeah, thanks. It's an interesting one again, and like I showed that slide with the various bodies involved in an LED project, and it is kind of huge, coming down from national level, from state level to city level. So it is a real issue, and I think Raimundo had a really good slide on the end there where it showed all his stakeholders, which was, it looked like hundreds, to be honest, or dozens at least. So it's a massively confusing picture for lots of people, and I think this is why we're seeing project stalling and not so many. We thought smart cities would be everywhere by now, but it's a slow rollout. Whereas I think lots of cities might not necessarily have the resource to do that. So, like I said, having someone, a political leader, or someone in the city, or someone in the utility that can take care of linking up all those different departments, all those different silos, can really help projects, because it's a really complicated picture. And I think, like we're seeing here, we've got different companies, different manufacturers are now working together, which wouldn't have happened 15, 20 years ago. They'd be direct competitors, whereas now they're realizing we have to form these coalitions, these ecosystems of partners, because we can't do absolutely everything ourselves. So it's the private sector linking with the public sector. Yeah, I think having that political leadership can really help. And like we said, having state level legislation, policy enabling that as well can really help push things along.
Great. Let me go over to Martin. Since you're our sole lighting fixture supplier, light source supplier, what is happening with lighting technology in the near term and in the future? What vertical markets are being impacted? Here, I have a range of questions. What about tunable lighting for people, plants, and animals? What about Wi-Fi networks? Feel free to talk about one or more of those.
Right. Tunable white or tunable lighting is interesting. It started back in the indoor mostly. We have seen some tunable white applications or cases and applications such as healthcare, where people that don't go out often, they would like to get some sense of the day timing and see some daylight equivalent, so warmer in the morning and getting colder in lunchtime, and then sunset kind of lighting. So it came up in the indoor and outdoor. It's kind of funny because we started back with a really cold light, right? The LEDs that were not that powerful at that time, and we all know it was phosphor on top of the emitting source, which was a really royal blue, and then we had to cover it to make it look like warm light, like an incandescent kind of warm. So we started back 6,000 and 5,000 kelvins for those who know lighting, which is really, really blue. And then we kind of end up saying, okay, we're going to take the moon as a reference, right? Which is 4,000 Kelvin, 3,500 kelvins roughly. And then we started deploying, and then we realized, it's not perfect. Some cities and some neighborhoods would like to have a warmer light, so 2,000, 3,000. So indoor we're trying to get more closer to nature, and outdoor we're kind of trying to mix and match our colors depending where we are. So the tuning is not really happening. I think they're picking their fixtures or choosing their fixtures based on the application, if it's a roadway versus residential areas. Obviously, we're trying to be in sync with nature, so we have really, really warm lighting for nature element where we don't disrupt, turtles and other animals. But the tuning, it's not really happening, other than maybe, as Daniel mentioned, RGB lighting, so entertainment kind of lighting, where obviously you change your colors, but it's less useful lighting. It's more about entertainment lighting. But I think it'd be coming. I mean, I've seen some mock-up with wall sconces where you could change the lights in buildings where it was important for them to have different type of look and feel, indoor and outdoor. But yeah, it's interesting to see how we're going to go, and if it will be adopted by utilities and cities later to be able to adapt to activities on site. So during the night, probably at winter time, you want to have a bluish kind of light, and maybe in summertime you want to have it more like a warm type of light.
Well, it's interesting because for those of us who have been active in the lighting community, there have been a lot of initiatives about, and situations and issues about color temperature, about lighting. the AMA came out a while ago and recommended a certain color temperature because of health impacts of blue lighting. Blue suppresses your melatonin, and melatonin is a cancer suppressant and allows you to sleep better. So there's that situation. There are some very niche markets in the horticultural market where the photoreceptors in plants are a number many more than the 3 humans have in their eye. So you can grow plants in different ways depending on your spectral power density. And then, of course, I know Kevin, myself, and Raimundo live in turtle country where turtles cannot see under 2300 Kelvin temperature. And in our areas of the world, at least in the legacy past, fixtures have been turned out when for those months where it's turtle nesting season. But there, arguably, there's some developing science there that needs to be agreed upon. But it's an area to certainly to watch. Martin, I think applications from a supplier perspective are becoming more vertically focused. Would you say that as an end user shops for a solution, they may be looking for, if they are a retailer or a school or an office building owner, that the applications are becoming more focused around those particular applications and not just light delivery?
Yeah, it depends, right? So from a lighting standpoint, perhaps from a system standpoint, I think it's the opposite, right? Daniel mentioned it really well that they're linking parking lots, with streets when it comes to controls to understand what's going on a little bit better. I think we've seen some cases where they would use parking lot data to manage gating in bigger parking lots that lead to residential streets, these kind of things. So I think, yeah, from a lighting standpoint, yes. I mean, obviously we're past the point of developing new type of LED technology. I think we got the point where we're stable here. The costs per lumen won't change that much. It's just about making sure that you have well-to application from a perhaps control standpoint, right? If you're looking at a parking lot, definitely you have different type of fixtures and a roadway, type of optics, but then it becomes how you control these lights. Will you control from the building, right? You want to use like a typical astral clock inside your building and get your parking lot controlled. Do you want to add more IoT devices on top of that? So you get controlled through a building management system, a road and street where you would be at a different place, right? Where you were controlled from remote locations. But from a light standpoint, how we're going to control these, I think it's going to be real similar when it comes to public. Public light is public light, wherever you are. When you get to retail, that's a good point. I mean, they have different needs, different type of, well, I won't go to the detail of that because it's mostly outdoor here. We're talking about smart cities, but different needs in indoor. When you think about indoor positioning cases, big retailers are adopting that. It might go to the outdoor as well. We never know. It could help shoppers for curbside, as an example, to get their purchases in a faster way. If you can understand where your material is between the shelf and the car, kind of thing. But yeah, I'm not sure if I did directly answer your question, but definitely from a system and control standpoint, we're seeing some similarities now, and everything is getting connected together somehow.
Well, I think one of the questions, and I have a collection of questions here, but I think the Li-Fi question is related to that. If I'm in a retail environment, I might get beamed a coupon perhaps when I'm in a shopping aisle about whatever it is I'm looking at. Mm-hmm. Our next question is probably towards Kevin. You could start off with this one. Your organization has deployed revenue grade metering to individual streetlights. Can you comment on the issues surrounding that endeavor? In particular, what are the accuracy standards for revenue grade electric meters? Maybe, and Daniel, you could weigh in on that as well.
Okay. Hopefully y'all are hearing me. It appears you are. The revenue grade really is a term that has it's a nickname term. It really is only relevant in that what does your state or regulating body require on the accuracy to be. So we use the term revenue grade, but what we're really saying is the device has a high enough accuracy to be used for billing customers. Now, for a utility, we're held to a complete different standard on this than somebody maybe running a shopping mall and they're going to sub-meter some of their tenants and do that type of thing. They don't answer to the Public Service Commission like we do. So these regulatory bodies have requirements and we adhere to them. And a typical utility in the United States, and Canada's a little different, their requirements are a little different, but in the United States, generally every state has a requirement that you have to be better than 2% accurate to render a bill on electric meter. Now, that to us as utility people is horrendous. I mean, we're like, we want to be, a 0.5% accuracy. And that term is, it's accuracy class, not percent so much. So we're going to say, 0.5. On our network lighting controllers, they are monitoring a very low load item. And we require to be a 1.0 accuracy class, or basically refer to it as 1%. And that is twice as good as what the Public Service Commission requires. We always want to be at least twice as accurate as we're required to be by regulations. So we're our worst, enemy, I guess you'd say. We don't want there to ever be any concern about the accuracy of these devices. So now I'll say that our NLCs go through the same meter testing as I mentioned earlier, as the meter on your house, the meter on your building. We test 100% that comes into us of our NLCs are tested at the factory, and we have a test record supplied to us. We randomly pull a percentage from every shipment and test those and verify that they meet our accuracy requirements. And only then are they released to inventory and to be used in the field. And then we have a provision that we have to be able to go randomly every so many years and remove that device and test it, and then remove it if it's not accurate, reinstall it if it is accurate. So we have, not only do we test them when we purchase them, but they are tested throughout the life cycle of their use. So it's not a one-time snapshot. So that's kind of the accuracy. The reason it's important is because we are measuring energy usage just like we do with the meter on your house, and we are going to render a bill. So if I have a shopping mall, for instance, that's got 300 lights in it, we would have all of those NLCs measuring the usage of that luminaire they're plugged into. And they would call that data back to our central management system. And our central management system will collect the 300 units and put them in a virtual meter. And then that will look like one meter for the shopping mall for the lighting. And then that will be combined, and on the customer's bill, they will have their lighting as a service showing the 300 lights. And then there will be a line item for the energy usage. And that's very important. If the customer is just on dusk to dawn, we will flat rate that. But if the customer has any type of dimming profile or uses any type of sensors for high-low operation, like the presence sensor I mentioned earlier, then we need to meter that usage because it's not dusk to dawn. With dusk to dawn, we can be very accurate if it stays dusk to dawn all year because the astronomical tables are very good. But when a customer wants to do something different, we want to meter it accurately. We don't want to guess. We don't want to estimate. We don't want to do anything like that. We want to measure. It's like when you pump gasoline. You might not like the price of it, but when you're done pumping, you know you paid for that amount you used. Nobody guessed at how much you pumped. That's just a good example. Let's measure it. Let's charge appropriately. And it's a very low cost because it's an off-peak energy usage because outdoor lighting tends, is at night.
Sure. Well, Daniel, let me go to you as a supplier of metering sensors. What are the concerns? It's not a trivial effort to make a 1% or more accurate meter. What are the metering standards around the world, and what are the concerns in selecting a revenue grade NLC?
Well, the technology exists. I mean, as Kevin mentioned, there are products on the market that are available right now, and there's a standard that's about to be published on energy metrology and metering and the classes and how to properly qualify or a product. That being said, there are some constraint. Kevin made mention of it. In Canada, we have Industry Canada that has some very specific requirement. Anything that one of them is that anything that is built or charged needs to have a human legible display. When you're looking at a street light 30 feet in the air, it doesn't make much sense to have an LCD display up there. The other problem is a seal. Anything that if you go to a gas pump or you look at your gas meter or electrical meter, it has a seal. There's no provision right now for a seal on the NLC or a fixture itself. You can normally most fixtures are made to be open easy with no tools. So it doesn't make much sense to say I'm going to put a seal on that if you're going to break it once you touch it. So these are difficult situation that we run into in different regions. One thing I'd like to bring up though is that I wish everyone was like Georgia Power and accepting the metering. What I've run into in some of the states or cities, I actually went in front of the PUCs, especially for lighting as a service when the utility provides the lighting to the cities. One thing that was quite easy to win is charge for what's working and don't charge for what's not working. Just having a profile of the light was on or it's been 10 days and the light has never turned on. So don't bill me for that. Come fix it and bill me afterwards. So that was an easy case to win. And it does bring quite a bit of money to the city. At least they're paying for what's working. Ideally, 100% of the lights would be up. It rarely happens. There's always something somewhere that makes it that there's a burnt light, there was lightning strike, there was a truck hit a pole, but at least I think it's fair. And it was a very easy one in that case.
Great. Hey, we've got another more general question. We've talked today mostly about the all these new applications, but what are the impacts upon maintenance and operations of having remote control lighting?
Yeah, I can jump in here and maybe I'll add to what Daniel said earlier. Hey, it's kind of funny, but we don't know how many lights we have. We heard that across the board a lot of time. And just by the fact that you can extract what light you're talking to, which light you're talking to, and where it is, it's an amazing progress here from a maintenance and operational efficiency. Mm-hmm. So within the LED drivers, as we've seen in slides, you can extract that data. Now we have the ability to have a MAC address, if you will, that you can read and paste back to the database on a standard format, understand which manufacturer made that light, what power it is or expected to be, and what kind of lumen output you have at the end of the day. And there's custom, memory banks, we call it, that you can have the color of the fixture if you want a type of pole. That on its own, it's connected lighting, right? You have to get that data, you have to connect your light, but that on its own is a huge improvement.
Yeah, I will add to that and agree with Martin on that. We began using that process of machine-to-machine transfer of data from the drivers in our luminaires, which are populated with data when they're produced. So what color they're painted, what lumen output, what distribution type the pattern is, part numbers, all that type of thing. We've been doing that for about, I guess, 7-8 years at least. And all that information is backhauled into our central management system. So we do know exactly what we're going to repair when we head that way. That's very useful. And plus we don't gather it. We let the machines gather it. We let our people work on safely installing the luminaire. And then we let the machines talk to each other. Just like when you use a printer and you plug it into your computer, these days of finding the drivers are over. The two talk to each other and then you print your document, So that's very important to us. I'll tell you what we run into practical though. You will almost snicker at some of it, but when you go to lighting controls, one of the realities of the whole thing is you find out that you have problems that you never knew existed. We call it the ghost you chase for 2 years. And so what happens is you actually have connection issues out in the field. Or you might have a loose neutral or a bad connection on a hot leg or something like this. There are problems that you really never knew before. And what happened is your repair people just kept going back out there and they throw another HID lamp up there and they complain about why they come to back to the same location so many times. And maybe after 10 trips, they figure out that there's an issue there and they fix the connection on the neutral and the problem goes away. And as you know, some of these people on this panel realize that in the right, city environment, sometimes this could affect the whole, blocks of lighting and be a real problem. What we found is that we were bombarded with issues for the first year of voltage issues that we didn't know about. And now when we would send people out there, they might say the light is working and we might say it is working now, but it won't be later. So please put a load on that circuit, load that circuit up so we can watch it collapse and make the repair. Or when we have a low output on a luminaire, we had this in the HID days. When we had a bad capacitor in an HID fixture, it would burn at partial wattage. Some people remember the very dark orange HPS lights and things like that. Well, with LED, we can have situations where we burn at part wattage too, but when we send somebody out there, they'll say the light's working, but really it's not. And what we have now is we know the problem before the customer calls, because the customer doesn't always call, especially if it's not in their front yard or in their parking lot. They assume somebody else is calling, or they don't necessarily know there is a problem of low voltage or low output, low lumen output. Now we know when we have controls. Knowing means you have to respond. You cannot ignore it. So, but once you get 2 years worth of this caught up, you have a system that provides better service to your customer, much better customer service. I mean, that's just what it's all about. And then you can, things kind of get back to normal. It takes about 2 years.
Wow.
Interesting.
We do a follow-up question on maintenance and operations, and I think it's actually Raimundo for you. You've reviewed the current smart city use cases of IoT and smart lighting at Coral Gables. What are your future plans and integrations? And in particular, what is the ROI and what are the key improvement metrics from the use of these technologies? How are you measuring all of this?
So depending on the stakeholder that you talk to, if you talk to public safety, so we have metrics, for example, on the impact on some of these smart technologies, lowering crime. For example, police can tell you that they have lowered crime 40% in 2 years using some of these technologies and analytics. And we want to continue that path, monitoring the impact of these technologies in public safety, emergency management, and other metrics. If you talk to the chief sustainability officer, he will tell you about that, the master sustainability plan, that by 2025, we have to have a 20% reduction in CO2 and also energy consumption. We are at 14% now when we started in 2015. So it's good progress. And if you also talk to the economic development, so we have economic growth, economic development, economic recovery goals, also working together with local businesses. They use our IoT also to help them tailor their strategies and to have high visibility over traffic, to improve their bottom line. And at this time, it's critical because of the impact of the pandemic. So we have metrics, KPIs in all those different areas, and we work horizontally integrating all those functions in the organization. So you talked before about silos. So we work together because every smart city project is a strategic project. Basically, you are trying to improve quality of life or solve a problem holistically through all those horizontal areas, to transportation, economic development, public safety, etc. So for us, that we have to survive disasters and crises, it's a matter of having a high visibility over the environment and using that data as insight to respond faster and to respond better, and to have good strategies to also to validate how the policies that are implemented are effective. Like I can tell you from a smart lighting controller how effective we are reducing energy, but I can tell you also from traffic sensors how effective we are with mobility strategies, or we can tell you also with other data we are collecting from the Smart City Hub how effective we are in public safety in other areas and citizen engagement. So the goal is more integration. So those frameworks that you saw, so they have different components, and each component addresses one of those areas that we want to improve.
Great, great. We've got about 6 minutes left, so we have time for one question, and then we'll do a final wrap up. Our last broad question is, as an end user, I'd like to ask about interoperability. Are all light fixtures compatible with all control networks and NLCs? Which standards should I be aware of? Anyone could jump in on that one.
Yeah, I'll take that one. And I have a fixture here, and you might remember that from Kevin's presentation. I think it was really similar. He had a Cobra head there and devices. I like to bring stuff, even if it's virtual. Is it okay, Jim?
That's great.
I mentioned before D4I. This is obviously a lighting industry effort, but actually it's where we get to IoT, connecting our devices on our own. It's probably easy, but when you open your infrastructure and devices to other industries, this is where you need to have a broader scope of work. That's our suggestion as how we should connect devices to fixtures. So I'm showing you this because I want to mention, I want to make clear for those that are not lighting geeks, like some of us on the call, that they understand what we're talking about. Talking about controllers, metering, we want to make sure that we can create plug and play devices, right? I was talking about future ready. So that's a way of making sure you can select your manufacturer today and keep it for long term, hopefully, but if not, you can change, right? And within that device, you can communicate with different ways. You can use mobile communication. So we've been through 2G, 3G, 4G, now 5G. Another example of upgrades that could be required. And Zigbee, LoRa, and there's different type of communication. And then at the bottom, you might want to elect to have a different type of motion sensor. So Kevin mentioned motion sensing, and now we're seeing more devices with beyond motion sensing functionalities, air quality sensors. Daniel mentioned flood detection and water ice detection. I mean, the same kind of flexibility here. So to give you the big pitch, you mentioned standards. The D4I is the one to remember because that's the certification program that certifies controllers, sensors, luminaires, and inside the luminaire LED drivers. So that's what I was referring to as memory banks and obviously power supply for LEDs. All of this ecosystem is certified under D4I. And then you can, as a customer, make sure that you're all your manufacturers are all compatible together, lighting related or not. And in more detail, maybe NCC 136 is a good reference. And then the global ones, since we know our IoT goes beyond, North America, so the global ones that are used and as well into NC 136 would be Zaga Consortium and DIA, which is now DALI Alliance. Both responsible for mechanical, electrical interfaces, and as well communication used inside your product. So outside, you keep it standard as any IoT initiatives, any industries. Inside your product, you focus on the efficiency of the communication. So I encourage anybody that has a smart city project, outdoor, mostly indoor, it's coming, to look at D4I and encourage your sensor manufacturers involved to have a look at it. Because again, if you simplify that interface to allow to use the lighting infrastructure as a backbone, I think that's a really good tool to help our cities to get smart city type level of project.
Great. I'm obligated then to go to Daniel. Once a D4I enabled fixture is out there in the field, are there APIs or protocols that you like to see as a control system vendor?
Yeah, we sort of realized a few years ago that there wouldn't be one winner. It's not as simple as either Samsung or Apple. There's many more players in the field. So the way we've approached it is, let's keep it open. Everyone that wants to play with another should be able to publish its API. It's a way to control. We've seen it both upstream and downstream. So we have customers that actually want to control our stuff, but don't want to use our API. So, I mean, don't want to use our graphical user interface. So we provide them with the necessary tools to build the control in their interface. And we see that, let's say, in telcos, where they don't want to go into nitty-gritty details of controlling, configuring a device, but they want to have an overview of where the issues are. They want to be able to schedule some stuff, some basic operation. So we keep the platform as a more in-depth control platform. And then at the other end, we're working with G, we're working with Telematics Wireless, we're working with a bunch of players in the field so that we can, the customer don't want to be locked in a corner when they buy a system. They want to be have something to be able to work with more than one supplier. So we're trying to keep it that way. And at the total other end, we're actually providing the data. We just released an NQTT type. So we're releasing the data and other companies can use it. I mean, we send the alarms, we send the metrology, we send the statuses so that somebody else can use it. So I think
Great.
that's the way to keep it open and functional.
Well, thank you, Daniel. And with that, we're coming to the end of our session. This really was truly very enlightening, and that's not a pun. I really want to thank Kevin Fitzmaurice of Georgia Power, Martin Mercier of Cooper Lighting Solutions, Daniel Noiseux of Dimonoff, Raimundo Rodulfo of the City of Gables, and Toby Morgan of the Climate Group for joining us all today. To those of you who attended, all of these presentations, last week's and this week's digital transformation presentations, are available online as a registrant for the next 3 months. And if you did like all of this content, I would urge you to visit the Smart City podcast on Apple, on Google Play, on iHeartRadio, and even on your Alexa smart speaker. So thank you very much for all of our attendees, and particularly for all of our guests and presenters today. Thank you very much, everyone.
Thank you.
Take care.
Thank you, Jim.
Thanks,
for the
everyone.
invite.
See you again.
Bye.
Thank you. Goodbye.
Alan there?
Hey, Alan, how was it? Tim and Alan, you're both, oh, Alan's unmuted now. Can I leave?
Alan's supposed to shut this off. I don't know how to, I can't shut it off. He's the host.